Okay, right now we have the function gx and hx, and we want to find the expectation of gx and expectation of hx. For part A, the problem 1a, the relation of the PMF is like this: pk equals p1 divided by k. Okay, so now we want to find the expectation. Follow the basic definition of expectation. If I have a expectation of gx, the expectation is considered all the possible outcomes. The possible outcome is gk with their PMF times pk. We add all the possible outcomes and their kind of coefficient, their weightings. So k is from 1 to 15, since I have 15 outcomes, 15 random variables. 15 outcomes. So since we have this relations, then we just plug in. So again, this is the outcome. We can, in this problem, we can say it's a function of outcome. And this is the weighting. So if we extend this summation, is g1 p1 plus g2 p2 plus g3 p3 plus to g15th p15th. And we know that the gx function is here. If x is less than 10, then it's 0. So this is 0. 0. This is 0. This is 0. Until g11. So it's g11, p11, plus g12, p12, plus g13, p13, and g14, p14, and g15, p15, which is p1 divided by 11, p2 divided by 12, and p3 divided by 13th, plus p4 divided by 14th, and p5 divided by 15th. Now we need to find p1. Well, the relation is always p1 divided by k, so it's p1. So now we need to find p1. And how can we find the p1? For the PMF properties, all the PMFs, the summation of the PMF will be 1. So we know the summation of like p1 plus p2 plus p15th will be 1, which means p1 divided by 2. p1, and then p2 is p1 divided by 2. p3 is p1 divided by 3. And p15 is p1 divided by 15th. This equals 1. Then you can find the p1 is 0.3014. So you can find the expectation of gx is 0.1173. Now we need to find the expectation of hx. Now we still know that this relation means x should be greater than 10th. Same thing that in the sample space where I have 15 outcomes. So the expectation of hx, again, every time you want to find the expectation, write down the basic definition first, and it is easy to follow that and find your answer. So the basic definition is the summation, because it's the discrete random variable. We consider all the possible outcomes. Here is a function of outcomes times their weighting. The weighting is the PMF. And the k is from 1 to 15. And we know now you can plug in that k equals 1, 2, 3, 4, 5, but only when k is greater than 10th, I have the number, I have the value. So I will have only h11 times p11, h12 times p12, to h15 p15. And this is h11, p11 is, oh, and this is for part B. So from part B, we know that pk plus 1 equals pk divided by 2. That's the relation. So here is p1 divided by 2 to the 10th. And the p12 is p1 divided by 2 to the 11th. And h15, p15 is p1 divided by 2 to the 14th. And h11 is 1. 11 divided minus 10, so it's still p1 divided by 2 to the 10th. h12 will be 2. 2 times p1 divided by 2 to the 11. So h15 is 5 times p1 divided by 2 to the 14th. Now we still need to find the p1. Well, the same way, the summation all the PMF equals 1. Then you find the p1, and finally you'll get the answer for the expectation is 0.00174.